I'm the team manager of TrueSec, responsible for doing the penetration testing and incident response that we do in our company. And we preferably help government organizations, banks and stuff like that to stay secure. We don't sell products, we only sell knowledge. So in all those pen tests, I'm kind of lucky because I get to see like almost every pen test. So I've been participating in more than 1,000 penetration tests in my career. And it's kind of interesting. You learn from that, like you see what are the common mistakes done and all that stuff. So this session is going to be a little different from what you may expect in this development-oriented conference. It's not going to be like code hacking. I think Fabio gave you a good example of how you can use a weak implementation in a web application in order to attack internal resources. I'm actually going to attack clients, but I'm going to use that to leverage the attack, and it's going to be very, very effective attacks. You're going to see them as maybe a little bit simple. There is some cool technology involved, so don't be worried that you're not going to waste your time. It's going to be cool anyway, trust me. I know, I'm self-confident in that manner. But still, it's the things that they will actually do to target you because it's simpler. You know, the real attackers, they won't go for the coolest hack. They will go for the easiest way in. And I think that's really important to understand. And it's also, I think there is a big change in the world, especially when we get assignments from new companies. You know, the startups or the new bright IT companies coming from nowhere. They don't build large, extensive infrastructures anymore. They have some Macs or PCs and they fire up servers in Azure or Amazon cloud. So if you want to attack that environment, whether you're a cyber criminal or you're just a penetration tester, you're going to attack a client. That Mac client or PC is going to hold the credentials to the cloud service. If that one is secure, then we're going to fail. If that one is vulnerable somehow, then we're going to succeed. So, and you being developers, I mean, most people aren't just developers anymore. So many are DevOps. They actually push code to production servers and stuff like that. I don't know about you guys in particular, but it's changing. I think the traditional IT technician is going away. If it's not gone today, it's going to be gone tomorrow. Developers are going to be here for a long time because we haven't developed all the future applications yet. So there's a huge space for creating new software. But regular IT, you know, running around installing software on systems, that's going away. Trust me, at least in the form it is today. So that makes your computer more important. Actually, from a business perspective, it's kind of interesting. So the first attack I'm going to do is pretty simple. I'm going to use a USB stick and put it in a computer. And you may think, like, how old can this be? Is this like an ISO auto-run feature? What is it? This is a simple Arduino microchip that costs like 150 Swedish kronor or 20 bucks, if you will, if you're US. And what you can do is you can program it to do different things. But basically, you can put it into your computer. So we programmed this with this simple Arduino software. And this is the simple code we wrote. And it will pose as a keyboard. So instead of just telling you it exists, I can actually show you how simple it is. Kind of nice. I'm going to run it. So this is targeting Windows, but you could as well target actually Android, or you could target Mac OS X, as long as there are some keystroke combinations that will eventually do some damage. Can you patch yourself against USB keyboards? I don't know. Do you wanna? So it's kind of tricky, right? So what this basically does, how many of you guys are like Windows oriented in a way that you can actually use a Windows machine as a professional? Who knows? Who knows? More than half of you guys. There could be Windows haters here. You never know. Well, if you look at what it says basically pose yourself as a keyboard, begin the keyboard functionality, and then enter some keystrokes. Wait for some seconds. This is because you wanted to. Maybe some drivers needs to get installed. This is a plug and play, but still sometimes some drivers will get installed. So it gives me 4 seconds. And then it says, please use the Windows key and the R. That will make the run prompt come up, right? And then I want to run a long command which doesn't fit inside the run prompt, so I'm actually opening a CMD and pressing enter, and then I'm starting PowerShell. I'm going to talk more about why PowerShell later. And then I'm running an encoded command, which looks like this. And then I'm going to minimize it, the window, and then I'm going to minimize the run prompt and everything and just run it. So that's what this one does. Kind of convenient. Then you may wonder, what is the worst thing you could ever do using some keystrokes, right? And I'll show you some nasty stuff you can do. So before you do that, you need to set up some kind of infrastructure. What is my objective, being a real attacker? Looking at me as someone who wants to put some real damage onto your computer or to your business. Well, my ultimate goal would be to install some Trojan or remote control software that would phone home to my attack platform so I can remotely control your system. Wouldn't that be nice? Would be pretty nice, right? So what challenges do I have? You may have antivirus, right? That's a potential problem. You may have some firewalling and stuff going on, who knows? But what you would normally care about would be antivirus, especially if you want to run known code. So just for fun, I'm going to use Metasploit on my attack machine. Do you know what Metasploit is? This is a framework, a toolbox filled with attack tools, and it's for free. So this is my attack system, and it's running this Metasploit application. And I'm asking you some questions here just to make you think. I know you probably know the answers already. Where would you put an attack platform like this if you wanted to phone home? Would you put it in China? Maybe that could be good from a perspective that the police may have an issue finding that server, but maybe it would be obvious that this is some traffic that is abnormal from this network, potentially. Who knows? I've been called into incidents when people saw traffic from China on a government agency and they got berserk, and then later on they realized it was Skype traffic, so who knows? It was peer-to-peer traffic using Skype. But so sometimes it's not dangerous. But what would you normally use? You would use an IP range that is completely trusted. Wouldn't that be nice? Where would that be today? Well, you guys are using the cloud. Don't you think the attackers are as well? Mine is located in Azure. So this is Microsoft Azure. I have a subscription here. I have virtual machines. And this is MS-Secure, the machine. So I'm terminal servicing into it. So this is MS-Secure at cloudapp.net. This is owned by Microsoft. So if you do a whois on cloudapp.net, it's a Microsoft domain. So on Microsoft IP addresses in a Microsoft domain, and you will see outbound traffic in that firewall going to mssecure.cloudapp.net. Do you think your IDS will stop it? Sometimes we see fun things, like people actually block this traffic. Then they will block all their access to Azure, so they will actually not be able to access services at all that are hosted by Microsoft, which, for example, Apple are hosting services in Azure, believe it or not. So it could be really fun implications when that happens. So I have an attack platform in Azure, in a trusted space of the internet. I'm using known malware, this Metasploit framework. And what I'm going to do is I'm going to put up listeners. I'm going to tell Metasploit, please listen to connections using an HTTPS channel over port 443. So I'm just configuring Metasploit to wait for Trojanized computers to phone home. And it's starting the payload handler. It's waiting for connections. I think it's kind of sad sometimes when I look at you guys and I think like, well, 2 years ago or 3 years ago, I could ask anyone, can I try this on your laptop? But you don't need laptops anymore, right? You have phones. So funny, it's like I'm looking for these PCs here, but I can't find them. So I'm going to have to hack myself. Maybe the demo dude in the corner running the screen, I don't know. But I've done this on stage in the US and stuff, where you put it on there. It's a risky demo, of course. You never know the configuration. But this actually works in 90% of the cases. I would say the wrong keyboard setup would maybe screw it up, because we haven't foreseen all the different keyboard setups. Stuff like that. Or power saves. You don't allow the USB to get enough power to present itself as a keyboard. Those would be the only reasons this wouldn't work. Antivirus, no worries. It will work, and I'll tell you why. So let's plug it in. First, you look at the attack platform. It has no connections. It's just starting the handler, waiting for connections. See if I can make it smaller. Maybe we can see something while it's happening. I'm going to minimize this. And I'm just going to plug this in. And I'm waiting. And it's doing what I told that it was going to do, and it's minimized. So if this is a logged on computer, it's now hacked, and I can see there is things happening on the attack platform in the Azure server. I can take it out. It's already hacked, so I only need a few seconds of your time. So if you plug in this USB for only a few seconds, even if you don't like it and you take it out, it's done its deed already. I gave one of these away at TechEd in the US. Like they saw the demo, and like I want it, you can have it. And then like a month later, I was hacked computer connecting to my platform. It's like, shit, I need to change my configuration. Stupid. I don't know if it gave it away or something. I don't know. So if I have antivirus and stuff, why wouldn't this react? First, let's just see what happened. Running this Metasploit framework, I have a lot of different functionality. One, I can do sessions, and then I can list my sessions. If this was a real attack platform, I would probably have lots of different sessions here. If I had like a botnet, it would be thousands. I can interact with any session of my choice. Sessions, interact, and just give it a number. So I can interact with this session, the Marcus computer. Yeah, I need to learn spelling. That's why I have a team. Please come here, help me to spell. So now I'm in the Meterpreter. Meterpreter is just another name for agent or Trojan, depending on how you look at it. This is the remote control client, if you will. So I'm in their system context. I can run code on that system. Let's do get UID. This is like a who am I. So I will get feedback from that system and see that Marcus is logged onto the Sony computer. I can do sysinfo. I can do all sorts of things on this system. Well, this is an 8.1 Windows. It works equally well on Windows 10. There are targets for Mac OS X, Linux, all that stuff as well. So Metasploit Trojans are multi-platform, if you will. Is this stored on disk, you may ask yourself. Where is this Trojan running? As of right now, and this is interesting, it's actually running. If I watch this, and this is only because I choose this method, it's running in PowerShell. It's actually here. I can actually see it. I can hide it, just so you know. And I'm going to show it to you guys, but I want you guys to see it. So this is PowerShell running. There is a PowerShell process running. And the reason we're using PowerShell is because PowerShell behaves like a sandbox. So what this USB stick actually did is that it wrote some PowerShell commands, and the commands was, please go to this web server and download some text. That text was a function in .NET, because PowerShell can invoke .NET. So basically, PowerShell invoked a function stored on a web server. So it never really touched disk. And inline, it just passed that function into the pipe of that PowerShell. And that function will actually run shellcode. That is the Meterpreter agent in RAM. So the Meterpreter agent, the Trojan, is running in RAM inside PowerShell. So the only binary executed was PowerShell, and PowerShell is not malware. Inside PowerShell on the fly, there is actually a compilation going on. So it's actually a DLL created if you want to be really detailed, but that is not it doesn't look like a real normal new binary that an antivirus would find. So it works all the time. 100% of the cases we ever tried. So we have this universal way of running malware through PowerShell without being detected. Pretty interesting, right? So now we have this computer. We're controlling this system right here. So what do I want to do? What could I do? Well, just to give you an example, I'm going to continue this hack later, but just to give you an example of the power that you have, and just to try to be a bit funny. You didn't laugh the last session, so maybe you'll laugh here. I don't know. But anyhow, you see, it worked. It wasn't even funny. Can you imagine if I pull a real joke? Now, anyhow, webcam stream, for example. What you need to realize is, I'm sitting on the attack platform, and I'm running the webcam on this computer. And so many people talk about the fact that you should not be local admin and stuff, and that's true. If you're running as local admin, you're exposing yourself as a local admin. If I was running a keyboard, I could run stuff as a local admin. Sure. But this is what you can do as a non-admin. You can do anything that you can do as a non-admin. And that's a lot. I can run a webcam. I can run Skype, being a non-admin, right? I can access files and resources. I can fire up applications. I can access the network shares. I can probably connect to that system on the internet. So there are a lot of things you can do. If I want to hide that process, for example, let's see if I can do this without killing it. So now the interpreter is here again. I can do a PS, and I can list the processes on this system. I will see the PowerShell process running, but there will be other processes. Let's look at some safe process that I could jump into and hide within. So let's use Explorer, for example. That is a pretty difficult one to get rid of, because if you do, you log out, basically, if you kill Explorer. So this is process ID 3392, so I can migrate to 3392. If you look at the target platform, you see the PowerShell icon here running. And if you go back to the attacker, and you migrate from that PowerShell process into Explorer, which will not really be a new execution either, because it's just an injection. Explorer is already running, so the antivirus won't care. Trust me, I know this for a fact. Then you will eventually see that this is successfully done. The PowerShell is gone, but it's still running, and I'm still controlling that computer. So if you fire up Task Manager or something, it's going to be pretty hard to be annoyed by the fact that you have Explorer running. There's no PowerShell anymore, and it's just Explorer, actually. There is no malware you can find in Task Manager. Sometimes we don't even use TCP outbound connection. Sometimes we even use DNS tunneling. So we make the target talk to its own DNS server. And then that DNS server will connect to our DNS server, and then we will tunnel commands that way. But that can actually be easier for an IDS to find. But sometimes that's the only outbound connection when we do real penetration tests. You're not even allowed internet access. You can imagine some of the environments we attack. Then you use those channels as well. You have to be really creative. The problem is, if you allow a bad guy to run code on your computer, you have a real issue. He will, if you have internet access somehow, he will as well. You can tunnel anything to anything, as long as there's bidirectional communication and you're eventually allowed access to your own IP somehow. You can tunnel TCP over Facebook if you're creative enough, or over Twitter, anything that can, pass data between two different entities. Nice, huh? You find this interesting even though you're developers? Nod your head, shake your head, or just walk away. Anything is good feedback. So, anyhow, looking at this, I migrated this. I can still run stuff, or get UID, whatever. So I still own this computer, even though I changed. I'm going to move into another example. This is a cloud server. So I don't have a large cloud infrastructure to hack, so I'm going to take this away from the equation. I'm going to continue my hack, but I'm just going to use another attack vector and use this on an internal attack. Because one option, if you look at this, is to get a USB stick on this computer. Another option, because if I only show you one example, some people walk away with, beware of USB sticks. So I'm going to give you two, so at least some of you will figure out that there could be maybe 10 different, who knows. So you never know. So another one, this is another attack platform. Oops. These are some virtual machines, so now I'm hacking my virtual environment. This is another Metasploit. So I'm just setting up another listener. But you know this now, you feel comfortable. You learned this already. So now this other attack platform is listening to connections. Where I put my evil code could be anywhere. So this is a target, a regular client. And in this case, this is evil code in a Word document. This is a simple macro. But still, the default behavior of macros would be that you will get a yellow bar that says do you want to enable active content or not. So whenever we do pen test, there's a huge chance of some people clicking that. And all it takes is one target. Since I opened this before once, it opens automatically. So if I look at this, it is it's going to be working. You see that there's a new session opened, like before. Why a doc document? It's so damn silly, but true. Well, we have showed too many Excel spreadsheet attacks, so now we show Word documents instead, because you're all very protective when we show you Excel spreadsheets. Another thing is that in the modern versions of Word and Office, they don't allow for XLS file anymore to contain macro code, but they still allow doc files. It doesn't have to be docm or something. You can still run macro code in regular doc files, and they don't look dangerous. So that's why. But these are merely examples. It could be a 0-day, but these are the simple ones that you can do. I mean, it's just a macro here. And the macro will actually invoke PowerShell and use that same function, but now everything is in the macro, so I don't need a web server anymore. So this is self-contained. I shut it down, and I'm on the attacker again. So I'm going to give you some other examples of what I would do normally. One thing that I would do is I would interact with this guy. And I would log, one of the things I almost always do when I attack a client is I start to log keystrokes. Isn't that nice, you guys having computers, punching things on your keyboards? And think of yourself as a DevOps now. Because now there is a keylogger on your computer. That would normally be integrated in your Explorer process that you couldn't see. So what would you do now? Well, you may, just as an example, try to connect to some resource. It could be a cloud resource or an internal resource. I'm just going to do net use just as an example, like net use. And I'm going to connect to the computer 10, 10, 10, 110 $. And I'm going to use the user administrator. Ever heard of him? And then some password, whatever. Oh my God, it worked. I'm so surprised. My own systems. I know my own password. Anyhow, I mean, if you were to connect to any resource when you have this agent in your system, if you're on the other side, this will repeatedly just send those keystrokes to the attack platform. So if I do a key scan dump, then you will see that he's connecting to 10, 10, 10, 110. He's using username administrator and the password of password with some shift and stuff. So I have his credentials and the IP is targeting. And can you imagine the strength of this if I get, this kind of code into some DevOps or some admin or sys guy? And this is sometimes how we do it. Apart from just parsing his file system, looking for those files where he actually stores the passwords in clear texting so that he can remember them, of course. I'm not going to show you that demo, it's too obvious. But still, it's very valid. So I think this is an important take-home. You need to really feel responsible for your computers. We have done some really extensive penetration tests lately targeting software development organizations because they develop very important code. The only ones who survived our testing was actually the ones that had like this isolated environment for developing that specific application, and they left their computer in that room when they walked home. They're the only ones who survived. I'm not saying that you cannot survive being on the internet and doing stuff, but most people don't do the right stuff from a security perspective. They don't. And then it's fairly easy to get some code in their systems. I mean, look at the Xcode or whatever that was, the development platform. If you can Trojanize something you download, it's equally bad. Fabio's example in the last session where he actually pushed some code to a server, whenever he was running that code, it could as well have been the interpreter agent. He would have a nice user interface on that server. I could have done this demo with a SQL injection. Then I would be running code on a web server or SQL server. Anything that can run code. I would just put my Trojans in there. And I can put known Trojans in there because I'm running them through PowerShell. Or I can modify them or do something else if it's not a Windows platform. We actually have a tool called AV Hide in my office. It would take any binary, patch it so it becomes undetected from antivirus. We're just changing the appearance of that PE file. You don't need to have the source code, just patch the way it looks and you reallocate. That's the story for another session. More time would be required. So, anyhow, well, we have some stuff here. Another important take-home, if you have a traditional environment, God forbid, if you're not just 100% in cloud, if you're still on-prem, then you may sometimes use that laptop in order to connect to internal resources. You may sometimes even be through VPN or, God forbid, actually go to the office and plug into your own internal environment. Then you may have access to resources that the hacker wants, right? So if I'm here sitting on the internet, and I'm controlling this computer here, which is also red, I may be behind this firewall and this filtering going on between the internal systems and the internet. Wouldn't it be nice if I could use this computer to attack internal resources? And of course I can do that. There is a command in Metasploit called autoroute, which will actually create an automatic route through these computers that I can target internal IP addresses directly. It will pose as a proxy, if you will, but a full-blown one. So I can just use TCP or UDP fully. So I'm not even going to do that because I actually have a flat infrastructure in my demo environment, but it would just be run auto route and then set the segment, and that's it. But it doesn't make sense now because my attacker and targets are on the same segment. I know there are always some people that can recognize what I'm doing, like, no. I see you're not using auto route. So I might as well tell you right away. So, sitting on the attacker, using that auto route, I could go back, I can background this process. So now, I still have that session, but I'm not in it anymore. I'm in the attack platform, so now I can do other evil things. But I can still route through that target. So what I'm going to do is I'm going to look for other things. I'm going to give you one example out of many because I only have like 10 minutes left. But I'm going to look for SQL servers. This happens to be a Microsoft environment, so I'm going to look for Microsoft SQL servers, MS SQLs. And this is another interesting thing targeting developers. Many times I find SQL servers on developers' workstations, and sometimes they're not using hard-to-guess passwords. So that's another way into a developer machine, or your server, your test servers, or whatever. So sometimes when I'm just on a network, I can start owning servers or development machines that can be important. They could have important source code and stuff on them, just by targeting SQL servers. So I'm just scanning this network for open port 1433. There are many different techniques to find SQL servers, but if they're using the default TCP port, I will find them this way. And I need to save time for demo purposes. So as I can see now, the 110 machine actually has the 1433 open. So I'm going to target it. And how do you target a SQL server? Well, you try to connect to it. There are two different ways of connecting to a SQL server. They can be in mixed modes. You can do SQL logons, or they can be NTLM integrated, so you can do Windows logons or Windows authentication. We usually go for the SQL logon because there's usually an SA account with a password that when they're internally, they're usually pretty simple to guess. So I'm just going to fire away a brute force attack targeting that IP, using passwords in this password text file. And this is all supported by Metasploit. So I don't need to know much more than just what commands to use. It's all built into one framework. So I'm sitting on the internet, exploiting, trying to log on with fade logons and logons and logons until you succeed. And you can see how fast this was. It's pretty damn fast. And on the 10.10.10.110 machine, log on successful with the SA count and a strong SA password. Do you recognize this password? It's in the manual. It's so funny, we sometimes still find it in production environments, because the manual says, please enter a strong SA password. Some people are like, okay, I will enter a strong SA password. It's funny. So now I connected. What am I going to do? I know the username and password, so why not use a module to run code on the SQL server? What code am I going to run? I'm going to run some PowerShell that would put the interpreter in memory. Obfuscated, of course, just for fun. Why? Because it looks cool. I could as well use a function to install an interpreter. I'm going to do it this way. And that's the wrong one. Here it is. So just execute MS SQL code. And basically what this does, if you know your way around SQL servers, it will basically enable XPCMD shell, and it will run code through a stored procedure of the MS SQL server. There are other ways to run code on the SQL server. There's SPOA create and other things that you can do to run code. But MS SQL shell is the most common one. Why does this work? Because I have high privs. Why do I have high privs? Because it's an internal system. Are there sometimes DMZ systems running in high privs? Oh yes. Are we equally surprised every time? Oh yes, even though I've seen it hundreds of times. I'm equally surprised every time. We're still surprised when we find SQL injections, which we do all the time. All these errors, that was scary. Let's see. That's failed. Could that be me, really? It was me. I forgot to use my... No, I know what it is. I was going to have a web server hosting some evil code, because my command was going to download that code and run it. Mimic it. Now I'm getting confused, too. This is the one I'm going to run. No worries. We'll just do it again. And if it doesn't work, I'll sing and dance, and I'll distract you so you won't even know what happened. That's what happens when you've done presentations for a few years. How can anything be wrong? I'm punching this in manually, yes, you know. Interpreter session 2 opened. Could you see how confident I was when I failed my demo? I am very proud of myself because I wasn't equally confident inside. Yes, you know, sessions. And as you can see now, I have 2 different sessions, so I can jump into that SQL server or jump back into the client. So I will build a list while hacking this network step by step. So what's the difference between owning a client and owning a SQL server from an attack standpoint, if you really want to compromise an environment? That's a question you may ask yourself, because now I have a server. Well, the servers are important. And they're not personal in the sense that it's not one guy using it all the time. And sometimes one guy is actually doing administrative work on a large number of servers. A headless guy. So do you think he normally uses one account to do administration of all these servers, or do you think he has like one unique account for each and every one of them? It's a tricky question, because if he has one unique account, you will find his remembering password list on his system that I probably own already. So it's not good or bad, it's like worse or even worse, I don't know. So anyhow, we always look, when you compromise your first server, and sometimes when you compromise clients too, you realize that there will be dependencies in this network. There will be reused passwords exposed on one system that you can use on other systems. Those are password dependencies or credential dependencies. That is the #1 biggest problem today that will take you from an initial compromise into a complete enterprise takeover. Microsoft has some statistics because they do a lot of incident response. And they say between 24 and 48 hours, that's the average, from the first compromise into complete control over the entire infrastructure. I couldn't agree more. We sometimes take more time because we don't want to mess things up. Because when we do pen tests, we don't want to damage or hurt the environment. But if you're an attacker, you're just going to run your tools right away. Unless you may be state-sponsored and you want to go really low and slow. So sometimes if they're slower, it means that they have more intent and they really don't want to get detected, not that they actually are worse at what they're doing. Many times when we've done incident response, we actually find out whenever a company has been breached and we do some real checking on the environment, we find malware that's been on the systems for maybe a year, sometimes more. It is damn hard to detect these attacks. But you need to realize that you may have important resources and you want to protect them, so you need to come up with some kind of strategy. And you need awareness. You need to know how these attacks are being done. I mean, you can always take that source code and those special important things and put them somewhere safe. We have that opportunity if we want to. Or a more safe behavior among the developers and DevOps. That can change the game for real. So, last 4 minutes, I'm just going to do a quick little hack on the SQL Server. Sitting on the attacker here, I'm going to interact with the SQL Server. Sessions, interact with session 2. And then sysinfo. And I am system on this computer. How do I know that it's a SQL Server and I was allowed to install this software? Get your ID. So it's not an old computer. It's in Windows 2012 R2. So, I mean, this is not something that just works on the old stuff. I mean, so many times they show you these attack demos on XP computers. You're not impressed, right? It's like, does this really work? These are not like zero-day attacks and vulnerabilities. These are configuration errors. These are weaknesses in implementation. So, you're just having a bad password, that's all. And if I was logging your keystroke, it wouldn't matter if it was a 1 kilometer long password. I'll still have it in clear text. So, connecting to this system, I can do stuff. I'm actually going to inject myself into the LSAS process. The LSAS process of a Windows machine is the process holding the secrets of the computer. It will hold your logged on passwords, for example. And I can see that this process is running in PID, process ID 516. So I'm going to migrate to 516. So now the Meterpreter agent is living inside that context. So it will get the tokens and credentials of that process. It will impersonate that process. So when it's trying to access resources, that process will itself will try to access those resources. And the LSAS process is allowed to read the secrets of the systems. To save time, I'm going to go into shell. I can always open up a command prompt from within Meterpreter. And I'm going to use some tools just to save time. There is actually functionality inside Meterpreter that can do this, but this is faster for me. This is Mimikatz. This is a tool that is for free, and it can extract secrets from Windows. We actually used to write our own tools. We were actually the guys inspiring this guy, so he credited us for writing this tool. But this is so much better than our stuff, so we're using his nowadays, because he put so much time into it, this Benjamin dude. So he's done an amazing job. But what you can see here are the secrets of the system. These are the encrypted passwords, or the hashed passwords to be more correct, of the computer account. But I'm already a system on this machine, so it doesn't matter. But whenever you log on to a system, you will actually leave your keys behind. So I will look for logged on users. And if I go up the list here, I will hopefully eventually find, I'm getting a little worried because I would have found it by now, I thought. Maybe no one is logged on. That would be a failure because of my time restrictions. Server, server, server. Okay, let's say for the sake of the matter that someone logs on to this system. Server 110. So the domain admin logs on with a super secret password. Oh man. I'm not joking. Damn. Yes. That was like a 50-50. Okay, it worked. So if I run this tool again, now there's a logon. Mimi.cmd. So thank you. Bye. Was that what it did, or did it do it all again? Wait. Okay, wait. I just don't know what happens. I'm just gonna do this and do shell again, and then back again. cd backslash demo dear mimi.cmd, and then now hopefully this logged on system has stored its credentials here, and the reason is for single sign-on purposes. Because whenever you're logged on, you don't want to enter your username and password every time you're going to access a share or something, right? So it has to be stored here in order for that to happen. So hopefully this time, you can see the administrator of the @rip domain. And these are his keys. So here, this is actually his hashed password. And you don't have to transfer this into clear text in order to access Microsoft resources. Because whenever you logged on, the hash will be populated and used for single sign-on purposes. So I can use it myself to connect to other resources. So what I would eventually do is connect to the domain controller. I can show you how I can find it, but I don't have time for this because I'm 2 minutes over time, and there's only 1 more minute before I'm going to let you guys off the hook here. But what I'm going to do is I'm going to connect using that hash. So I can just connect using the SMB PSX functionality. I can say connect to this 100 computer, which is the domain controller, use this Ming DADM or administrator DADM username, and put the password hash here, and I can actually connect to him. For some reason, this is a little bit unstable. It always works the second time. Don't ask me why. So if I do exit, and I background again, and then I do this, I can use these credentials to connect. It always fails the first time. Wait a few seconds. And then do it again for some strange reason. It works. So now we'll have a third session on the domain controller. So this is the get UID. I'm now on the server. Wait, get UID. It sometimes takes some time for it to actually install its functionality. So now I'm system on that 100 system, and this is the domain controller, SRV 100. So if I do background sessions, I now have 3 different computers uncompromised. And if I'm on this last one, I can just inject myself into the LSAS process, and I can steal all the credentials of all the users in the entire domain and impersonate anyone I want to. And thinking about it, that's usually because one guy got malware on his system, or one SQL server allowed for an interpreter to go in there, and this process is starting. So before you guys want to leave, I'm going to say thank you so much for listening. If you have questions, you can stay here afterwards and I will take your questions. So thank you so much for listening. And yeah, now is the time where you do your applause. And if you want to contact me for any reason, I'm unfortunately not going to be here. I have my TrueSec team. They actually have a booth here. But you can take a photo of my email address if you have any questions or anything. Marcus, the shortest one is actually at TrueSec.com. So if you have any questions, whatever, if you can translate this into clear text, then you will actually be able to use it. So thanks again.